To end this section, let's take a look at example number 4. A survey here was given to 125 seniors at a particular high school, and they were asked what their plans were after high school. So the results were as follows. We can see here that some people said they were going to plan to go to a 2-year college, some to a 4-year, some were just going to go start working right away. Others planned to join the military, and there were a few other people that were going to do something else. Now, I can easily go ahead and translate each of these individual frequencies into a probability. And the way I can do this is in part A, using my survey, I can build a probability model. That is, if I was to randomly pick out one of these students, maybe I had like a big roster of all of their names. If I randomly picked one of these students, what would be the chances that they fell into one of these 5 categories? Well, if I was to take a look at the first category to try to find a probability for it, since everything here is going to be equally likely, I would see that I'm going to end up with 65 out of 125. Now, if I crunch this out on a calculator, I'll see that that actually turns into exactly 52%. I can do the same thing all the way down the line. 37 out of 125 gets me a 0.296. 13 out of 125 gets me a 0.104. A 4 out of 125 gets me a 0.048. Oops, sorry. It should be 6 out of 125 gets me a 0.048. And then a 4, oops, that should be 125. I'm all over the place. And then a 4 out of 125 should get me a 0.032. Again, if I add all those up, I should get a total of 1 for 100%. So notice then I can easily start to see how I can answer a question like part B. What are the chances that a randomly selected student that I pull out of the 125 is someone that plans to get a job? Okay, well, again, that would be really easy to see. I'm going to go ahead and give this category of get a job a letter so it's easier to talk about. How about J, J for job? So I'll say the probability that J would occur ultimately appears to be, well, exactly this probability that I have up here, 0.104, or about 10.4%. Now again, what does this mean? Well, this means that if we were to repeat our selection over and over, roughly 10.4% of the students selected would be those who plan to get a job after high school. This is the idea that we talked about at the end of the last video, that my probability is giving me an understanding of what would happen if I repeated this process over and over and over. Obviously, in the short term, if I just select one student, they could come from any of the categories. They're very likely to come from the first category, but they could really come from any of them. So that what this number tells me is what I would expect to happen if I repeated this selection over and over and over again. Now, we have one additional definition here to kind of end the section, and it's what we define as an unusual event. We'll say that an event is unusual if it has a low probability of occurring. Typically, that would be if it has a probability of under 5%. So if I take a look back at, oops, a little typo here, what I'm working with in example number 4, what would be considered unusual events here? Well, it wouldn't be unusual to find a student that is planning to attend a 2-year college, but the percentages that fall under 5% would be join the military, which is at 4.8%, and other, which occurs at 3.2%. So here I could see that the outcomes, or you could call them events, of join the military and other would be unusual. Again, they have probabilities that are under 5%. And we'll use this idea of unusual events repeatedly throughout the sections to come, because we'll often want to ask whether or not something that we're measuring a probability for is likely or unlikely to happen. Is it usual or unusual? And we'll always have this 5% cutoff mark like we did here.